Yeah, perfect.
Okay, fine. Yeah. Okay, so my screen is visible to everyone, right?
Yes, sir.
Yes, sir. Yeah. Okay. So yeah. Okay, so we will start now. So we will just start with the basics. Okay, so before that, I'll just have a quick introduction on myself. So my name is Srijit, and I have almost 13 years of experience in IT, and I'm currently working as an big data architect in one of the company. Okay, so that's all. Today agenda is like so your requirement is to install and configure the Hadoop. Say like we have like three kind of installation. So one is standalone, then pseudo distributed, and multi-node installation. So that is the target today. So we will will try to complete everything within next 3 hours. So before we start, I just wanted to go through the like the very basic slides. So maybe like if you are if you know the things like we will just like skip this session and all. I mean to say like skip the slides. So I hope you all are aware like what is big data. So the data set which is very huge in size, that is called big data, correct, right? So maybe like in like petabytes of data, correct, right? So you have the base idea, base knowledge on this, right? Big data.
Yes, sir.
Yeah, okay. So, like uh, where this data is coming from. So, like now, like we have various sources of data. So, say like, like machine data is like real-time data sensors, for example, like security cameras and all, correct, right? So that will be having, that is one of the source of the data. And the another source of the data is transactional data, say like records, payments, invoices and all. For example, if you swipe your ATM card and all in your any of the nearby or I mean to say like any ATM machines, so like that data will be processed in the back end, right? I mean to say like maybe like in OLTP, like Oracle or somewhere, you are like that the transaction details are getting recorded, correct, right? If you do that transaction in your bank, that whatever the like the amount you withdrawn, the time, date, all those details will be updated. So I'm just telling that's an example of a transactional data. Again, the another type of data is social media data, like tweets or comments in the Facebook. All these are the examples for the all these are just the examples for the data sources. So you can see like there is like a huge number of sources. You can see like in this slide itself, like security cameras are the logistics. YouTube is again source of data, Twitter or like in the like Instagram, like lots of like sources are there, right? So like each and everyone is contributing huge, like data. For example, you are just using your mobile phone itself, right? So imagine like you are just taking your photos or making the comments and all, right? So you yourself like maybe like a 1 GB of data per day you might be like uploading to internet or somewhere. So uh, I'm just telling it's just a source of just an example for the source of the data. Okay. So now we have to understand where we use this big data. So if the data size is huge, we need a framework to process the big data, correct, right? So that framework is called Hadoop. So before coming into that, where we use this big data, for example, we use this big data in all these use cases like healthcare, aviation, research, UIDAI. I'm just telling one example in this. This is our Aadhaar project, correct, right? So there will be millions of records, like your fingerprints are there, like your name, your address, all these details are updated in this UIDAI. So it's called the our Aadhaar project, right? So it's like again that if you consider the total population in India, whatever the crores, so that much petabytes of data will be there for each and everyone. So where we save this data? So for that, I'm just telling we use the for processing those kind of very huge data, we need a framework. So Hadoop is again we use that. So uh, in this Aadhaar project, we use the Hadoop framework for the processing purpose. Because with the traditional database management systems like Oracle or like MySQL and all, we will not be able to process that much huge data. So there is a limitation for our MySQL or Oracle server and all. So that's the reason we for this kind of projects or these for these kind of use cases, we use the Hadoop framework. So I'm not going into deep on all these use cases. I'm just telling where we use that. And if you see here how the if you see this slide, you can know how the data is growing. So if you see this graph from 2006 onwards, there is an exponential growth in data, because if you remember in the year of 2009 or 2010, we had VSNL or BSNL broadband connections that time, maybe that the speed was such a 4 kbps and all. So and we had no options like Twitter, Facebook, and all that time. So so that time you see the data growth itself was very less. Again, from the year of 2012, 2013 onwards, everybody started using multiple applications and all. And it's exponential now, 2020, so if you see here, Twitter process almost 500 millions of messages per day. And these are just the examples, okay? And if you consider Amazon, we have the cloud provider, right? So they have the S3 bucket storage, which we can use for storing the data. So with that Amazon S3 itself, per day, 1 billions of objects are getting created and added to that S3 storage. Okay. And coming to the Facebook, users generate almost 4.5 billion comments and likes. So this is in the in 2020, 2021 on so the data growth is very huge now. So that's what I wanted to say. So, so you understand, all these, there are different sources of the data. So how we can process this much, huge data? So we need a platform which could address all these, whatever the issues and challenges. So we use the Hadoop framework for processing the big data. So Hadoop is an open source framework for distributed processing of large data across clusters of commodity computers using the simple programming model. And this project is being managed by the Apache Software Foundation. So it's an open source software foundation, and they take care of that. There will be the millions of people will be working on this Hadoop itself. Maybe they will add more features to this Hadoop, and they will publish it. So if there is any bug, and if somebody finds any kind of bug in this Hadoop, there will be millions of people will be working together and fixing this whatever the bug. Again, they will update that the repository and all. So that's what is Hadoop. So I'm just giving an like a base overview. I know like you already gone through all this. And this Hadoop was created by dog cutting. And before we go to the practical, you have to understand what is a distributed file system. For example, imagine you have like one server. Okay, this is your imagine like it's your desktop, and you have like an disk space. The hard disk has only 100 GB of data. Okay, that is a maximum data you can write to your this machine. Imagine like you have like 1 petabyte of data to be written here. So is it possible for you to write that 1 petabyte of data to this your single node? It's not possible. Even if you consider you can extend the hard disk, maybe in market, it can be this is 100 GB, and imagine like you are adding one more hard disk to this. This is the this is your server. Okay, it already have 100 GB, and I am just telling you have like 1 petabyte of data to be written to the server. So is it possible? It's not possible, right? 100 GB. So if you want to add more storage, what you can do, like you can just purchase one more hard disk, and again like you can 100, still like 100 GB you can add. So still it is 200 GB, or the maximum size available like in the market can be like 8 TB or 10 TB. That is the maximum you can have. Okay, if you connect also, you can store only this much data, right? 10 plus 100 GB plus 100, only this much. 1 petabyte you cannot save. You cannot save this 1 petabyte of data in a single machine. So if you use the distributed file system, what we do, like we will have n number of computers. So instead of saving on a single node, what you do, you will purchase like hundreds of servers. So like say you will have like an a place where you have like hundreds of servers. So like this, all these are servers, and like this 1 petabyte of data is there, right? So this 1 petabyte of data, what you will do, you will distribute this data. I mean to say like this, so you can split this data, correct, right? For example, 10 TB to this node, next 10 TB to this node, and next 10 TB to this node, and next 10 TB to this node, and like this you can save the data in multiple nodes, right? So that you can save this 1 petabyte of data. So this kind of concept is called distributed storage. Okay, so if you see the definition, when a data set or file outgrows the storage capacity of a single disk, it becomes necessary to partition it across multiple disks. So file system that manage the storage across a network or disk from different machines are called distributed file system. So if you see here, how these multiple nodes can be connected. So you have like multiple nodes are there, right? So how you can connect each? So you will have, definitely you will need a like network switch, right? So it will be like with in the data center you will have like network switch. All the machines will be connected through this switch, right? Like at least the basics of the networking, correct, right? Because like these nodes needs to communicate each other, right? So for that purpose we use the switch. Okay, so you can see here like a switch is there. Again, in the data center, like there is a concept called rack. Rack means I'll show you just for your awareness. So you can you can see multiple images here, right? So if you see this or this image, like this is called rack. Okay, this is rack 1, rack 2, rack 3. It's just like a tower. Like you can all these are the blade servers. You can just plug in you can insert that server, and if you don't want that, you can just pull away that server like that. It is like it's like a plug and play kind of thing. So if you see here, like 1, 2, 3, 4, 5, 6 racks are there, and this single rack has how many servers are there? These are called rack mounted servers. 1, 2, 3, 4, 5, 6, 7, 8, almost like 50 servers are residing on top of this single rack itself. So this is a single one rack. This is another rack like that. So almost 5 racks are here. Each rack hold almost 50 servers. So coming to this slide, you can see here this is an like a single rack, again like a rack. On top of the rack, in a single rack itself, there will be multiple nodes. If you see here, this is a single rack. It has node 1, node 2, node 3. So all these nodes has to communicate each other. So to communicate each other, we need a network switch. If you see here, rack switching, on top of a single rack, there will be a switch. This is another rack. It has an rack level switches is there. So this also has another switch, and like multiple nodes are there. One, two, three nodes are there in this rack one, and uh, another 3 nodes are there in the rack two. So like this. So we use the distributed file system concept for storing the data. Correct, right? If it is 1 petabyte, again, that 1 petabyte is split to multiple like chunks of data. So say like 1 TB landed here, another 1 TB here, another 1 TB here, another 10 TB can be here, another 500 TB here, like that. So it depends on the storage available on these nodes. So so on top of the rack, you can see this is a rack switch, and again there will be like a master switch will be there, because if this node want to communicate, for example, I'm just telling you a scenario. If the node 1 want to communicate to node 6, how that data packet will flow. So this packet will start from through this switch, it will hit here, and again that data packet will go through this master switch. This is called a leaf switch. Again, again that data will pass through this. Another switch is there on rack 2. Like this, that data flow will happen. So I hope you understand like what is a distributed storage. Can you just like if you have any question on this, like you can just let me know.
We got
Got right? Okay, yeah. So again, we need to understand like what is the advantage if we use the distributed file system. For example, uh, I have like a 1 TB data to write with a speed of 100 Mbps. Okay, so 1 TB data I have to write. So for example, I have a single server. I am telling you 3 scenarios. So you have to listen carefully on this slide, okay, because this is you need to understand this well. So imagine like I have a single server and I have a single disk, and that disk size is 1 TB. Okay, and what is the speed? Like it is 100 MB per second. That is the maximum speed. So if I want to write 1 TB of data to a single disk on a single machine, it takes almost 175 minutes for write operation. Okay, but instead of that, if I use 10 servers, each server having like 10 servers means each server having single disk. So 10 disk is there, correct, right? A total 10 disk, and disk size is 100 GB. So 10 into 100 means it's 1 TB, correct, right? So in this case, in the first case, it is a single disk and I am writing 1 TB. It took 175 minutes to complete. In the second case, I used 10 servers. Each server is having 100 GB disk each. So what will happen? Parallelly, it will write this 1 TB data to 10 disk. Correct, right? So what is the time taken for this process? It took just 17.5 minutes to write, because instead of writing to a single disk, we are writing to almost 10 servers parallelly. So it took 17.5 minutes for the write operation, because we are splitting and parallelly writing to multiple disks. So instead of the 10 servers, if you go for 100 servers, and 100 servers means like 100 disk, and or the capacity of a single disk is 10 GB. So If instead of 10 servers, if you use 100 servers, what is the time it takes for the write operation? It is like instead of 17.5, it took just 1.75 minutes. This is clear, right? Any
Yes,
doubt? Yeah, because it's writing parallelly to multiple nodes. That's it. So that like the time is getting reduced. Instead of single disk or like on a single server, it took 175 minutes. Here 10 minute, 10 servers, so it took 17.5 minutes. Here instead of 10 minutes, like 100 servers means like it took very less time. Again, like if you increase to 1000, it will be like again time will be reduced. Correct, right? So yeah, so now like I said like what is distributed file system. So Hadoop, like we use this Hadoop framework. Why we use this Hadoop framework? We use this Hadoop framework for processing the big data. Correct, right? And coming to Hadoop, like we have two different components. One is the like we have to like one is the storage and the another one is the processing layer. So storage layer is called HDFS and the processing layer is called MapReduce. Okay. So in the case of like a processing, we use the parallel processing or distributed processing. Uh, okay, so Hadoop components means like HDFS. We go through that. So Hadoop distributed file system. So distributed file system that provide high performance access to data with fault tolerance. And this is the storage layer of the Hadoop HDFS. And MapReduce, it's again like a programming model, and we use the key value pairs, and this is a processing layer of Hadoop. So like I will just give in so I explained you like why we use the HDFS. So it's used for the distributed storage. Again, MapReduce, or like where we use that. Okay, I will just tell you a very base example. Okay. So like imagine like you have like a data size of almost 1 petabyte. Size is 1 petabyte, and like in this file, like so the imagine this is a text file, and I just wanted to perform an like like a word count on top of this single file. Okay, I mean to say like there will be like if it is a text file, for example, like there will be like a n number of occurrences for a single word, say like India. So like hello, how are you? There will be like a millions of occurrence for this word India, correct, right? So I just wanted to like find the occurrence of this word in this 1 petabyte file. So what you can do, like you can write a code in your computer to read this. If you have a single machine, imagine like if you have, if that machine is having that much like storage and all, you can write a like a Java code to read this file and like to find the occurrence of all this India, this word. So what will happen, like this is a single machine, and this entire data has to load, and like it has to read like blah 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 one by one, and it has to. It takes a huge time. For example, if you do a query by using a single machine, it takes almost imagine like 24 hours to complete this job. Imagine like that now. Okay, so 24 hours you took for if you use a single machine to process. So in the case of distributed processing, what you will do, you will have like a n number of compute machines will be there. Say like this is another computer, another computer, another computer, another computer, another computer, another computer, like this. So distributed processing means like you will distribute like that processing to multiple nodes. So that means like you are dividing that work to multiple persons, like that you can imagine. So I just split that data. Imagine like this. I have like 1, 2, 3, 4, 5, 6, 7, 8 worker nodes are there. So I'll split the data to 8 times, okay, like this. So this single file that like first split I load to here and run that corresponding, like whatever that program here to process this. Again, like, like the second split, it will be processed by here, and third split will be processed here, fourth split will be processed here, fifth will be here, sixth will be here, and seventh like that. So here in this case, what will happen? Instead of processing this entire data by using a single compute unit, we are using multiple computers here, right? So, like multiple nodes will process parallelly. That means like this will process few data here and another set of data this will process, and this will process another set, like another, and finally this output will be combined, and you will get the output. So this concept is called distributed processing. At least I cannot like I just try to explain in a very light way. I'm not sure like whether you get it or what. Can you just let me know like you understand, right?
Yes, sir. Yes.
Yeah, because I cannot talk much in deep also, because that's a limitation. Because I cannot become too much technical also. That's what. Yeah. Okay. Yeah. So now, so like so for that processing purpose, we use the MapReduce. So it's a programming model or like a program with key value pairs, and this is the processing layer of Hadoop. So if you see the different components of Hadoop, like for the storage layer, we use the HDFS, Hadoop Distributed File System, and for the processing, the map, it's yarn. Yarn itself is called, that is called MapReduce itself. So the complete full form is yet another resource negotiator. So that is called yarn, and like so this is the like for the processing, the master daemon responsible for the for the processing, the master daemon responsible is resource manager. And for the storage layer, the master daemon responsible is the name node. And there are like two slave components also, data node and node manager. So I will tell you in deep like when we start. So in an like an enterprise, like like this will be the setup will be like this. Okay, I mean to say like there will be like a n number of data nodes will be there, 1, 2, 3, 4, 5, 6, 7, 8. So 8 nodes are there, you can see in this environment. Okay, so if you have like some data, that data will be split to multiple blocks and it will be residing on all those nodes itself. And if you want to perform any processing on top of that single file, that processing will happen parallelly on all these nodes, so that like it will have the maximum throughput for that operation, and that job will be also very faster. So that's how it is. And so we have to understand like what is HDFS. So HDFS is a file system written in Java, and it is just based on the Google file system. So and it's like in a logical layer on top of the native file system. The actual data will be residing in the ext3 or ext4 file system only, because these two file systems are Linux file system. So actual data will be residing on top of this Linux native file system only. And if you load the data is distributed across all the nodes. So that means like that is called a distributed storage, right? If you it will split to multiple chunks and distribute to multiple nodes. That's how it is. So now you have to understand like a Hadoop HDFS. Split large files into small chunks known as block. So with this we will complete the theory. Okay, 1 second. Imagine you have a text file called like abc.txt. Okay, and the size of this file is for example like 256 MB. Okay, so So we need to understand like what is like block size. Okay, so Hadoop HDFS split large files into small chunks known as blocks. So in the Hadoop we define like what is the block size we need in a configuration file. So so in the exercise whatever we are going to do, so we will keep this 128 MB as the block size. So if 128 MB is the block size, if we define in Hadoop, so how many blocks will be there for this single file? So it will be two blocks, correct, right? Because it will be like this is a block one and this is a block two. Single file has block two, two different blocks because we define like what is the size of this block size. Default block size we define as 128 MB. So how many blocks are there? So here it is 128 and here it is 128. So two blocks are there for this single file called abc.txt. So I'm just telling another example. So I have one more file here. Okay, the size is 300 MB. Imagine. So how many blocks will be there? If the default block size is 128 MB, if you split that file, first file will be having first block will have 128. Correct? Sorry. So it will be like this is block 1, 128. Another block will be there 128 and the remaining will be like it's a very small size. It will be so it will be like this. Okay, so 128 MB. This is the first block, block 1. Next one is 128 MB, block 2. And the third block will be 300 minus 256, right? Just 44 MB, block 3. So in the like Hadoop HDFS, this is how the uh, how the blocks will be created based on the file size. You have any? You understand this?
Yes, sir.
Yeah. Just a second. Yeah. Hello. പറയൂ. No. ആ ആ ആ ആ ആ ഇത് ഞാൻ ഇപ്പൊ നോക്കുന്നുണ്ട്. അത് ആ ആ ആ ഓ ശരി. ആ അല്ല ഓപ്പണിംഗ് ഞാൻ ട്രൈ ചെയ്തിട്ട് കോയന്മാര് നോക്കും. ഞാൻ അതിന്റെ റോൾ കൂടി നോക്കിയില്ലേ. ഞാൻ ഒരു വൈകുന്നേരം വിളിക്കും. ഞാനൊരു ക്ലാസ്സിൽ കൊടുക്കാം. ശരി. ഞാൻ ഞാൻ വൈകുന്നേരം വിളിക്കും. Yeah, sorry guys. So you understand, right, what is block and how it is, how we calculate the block size, correct, right?
Yes, sir.
Yeah, okay. So, and if you see here, like every file is split into blocks. It is shown you. This single file is split into blocks. Here in the first case, it is divided to two blocks. In the second, because it was 256 MB, default block size, which I defined was 128 MB. So this is a cluster level, like the block size will be defined in a cluster level. So the size is 128. So here how many blocks? Two blocks. Here the file size is another file. Okay. Uh, Sri.txt or something like that. Okay, so 300 MB. So in that case, how many blocks will be there? 128, 128, and next block is 44 MB. Okay, so every block is replicated 3 times by default, and block is never replicated on the same node. So you have to understand like what is replication. Okay, Replication means like, for example, if you write this file, I'll go through this slide. Okay, so like block. Okay, so this is a Hadoop cluster. Okay, I have like one name node is there and four data nodes are there. So data node 1, data node 2, data node 3, and data node 4, you can see here. And I have a file with a 300 MB size. So 300 MB means like I can say like abc.txt. And default block size, this is again a cluster defined one, dfs.blk size 128 MB. And okay, so this is already defined. Okay, so this is like in a global value we defined in one of the configuration file. So you are a user and this is your file, and I am just uploading this abc.txt. Its size is 300 MB, and how many blocks will be there? So first block will be block 1. This is 128 MB. Second block, what will be the size? 128 MB. And third block, what was the size? It was 44 MB. Okay, so this I'm talking about this file itself. So it's split like like our Hadoop itself split that file. When we store this, it the Hadoop split that to three different block 1, block 2, block 3. So what will happen if you have a single copy of the block? So imagine this block 1 is residing here, and like uh, this is not there, this is not there. That means like these nodes are down. Imagine like that. So you have a single block here, right? That means like block 1 residing here and block 2 residing here and block 3 residing here. So if the remaining nodes are down, means like you have a single copy of this block here available here. So if this goes down, you will lose that data, right? Because like if somebody try to read this abc.txt, if this machine is down, means like like only block 1 was one is the replication is not there. In that case, if this is down, means like you will not be able to read that data, right? To avoid such situation, that means like in a cluster there will be like n number of nodes. If the block 1, you can see here block 1 is here three replicas are there in this cluster, 1 2 3, like like if this goes down, it's fine. We have two copies available here. If this goes down also, still you have one more copy available here. So to make sure that redundancy is there, we are we Hadoop will always have the replication factor. So here in this block 2, again, like you can see where the block 2 is saved, this three replicas are there. So block 2 means like it is in this node, it's there, here also it is there. So if this node fail also, it's okay because we have data, this block on these two nodes. If this goes down also, we have here. Or like a block 3, block 3 where this, so so what is the worst scenario in this case? Like imagine like this block 1, this node went down, this node went down, and this node also went down. In that case, like we will not be able to read the data abc.txt because the block is missing, because all the replicas wherever it is residing, that node is like it's not in on state, right? So we will not be able to like read any of the data. That means like our data is lost in this case. This is clear, right?
Yes, sir.
And so now you need to understand what is a name node. Okay, so for example, I'm an end user, say like so I'm an end user and my name is Johnny. Imagine like that. Okay, I'm just uploading this abc.txt to Hadoop distributed file system. So like what a Hadoop framework will do, it will split that data to blocks based on the block size. So it split to 128 MB, 128 MB, 44 MB. So now like who did that? As like like splitting and all, like this name node only this. So name node will take care of handling the metadata. Metadata means like data about data. So that means like when Joni upload this file, what are the details this name node will save? So this has the details like this. Okay, like file name Joni, like who uploaded this? Sorry, abc.txt, right? And who is the owner? Owner is Johnny. Like it will have all the details. Where the blocks are, how many blocks are there? 3 blocks. So block one residing in where? Data node one. Correct, right? Comma. Again, it is in residing in data node 2 also, right? Data node 2, comma. Again, it is residing in data node 4 also. Correct, right? So this is called metadata information. So this name node will save the metadata information about the file. That means if somebody, for example, Johnny uploaded this file and like it is uploaded already. So once you upload this file to the HDFS file system, the metadata information is updated. Okay, metadata. So this name node will have all the details where this what is the name of the file, what is the ownership, who created, how many blocks are there, where these 3 blocks are residing. If someone else wanted to read this file, like it's already uploaded, say like after 1 hour, one of the another team member logged into the cluster and she wanted to read the abc.txt file. So what will happen? This read request will hit the name node because like this file is split to blocks and this Johnny does not know like where the blocks are located. So that request will hit the name node and this name node will have the metadata information, right? So it will tell like like to the so the client will get the details like abc.txt is the name of the file. It is residing in block 1. Like block 1 is residing on data node 1, 2 and 4. So that read request will hit on like one of the here. So it can read that first block from here. Again, second block 2 details will be also there in this metadata. It can read from one of these copy. And the third one also, it can read from any of these 3 copies. So just for the redundancy purpose, we have like 3 copies of the blocks. This is clear, right? I know like you have the basic knowledge at least. Yeah, it's okay, right?
Yes, sir. Yes.
Yeah, okay. Okay, so that's how. So like we go through the Hadoop distributed file system features. So it has like the features which are shown here: high performance, fault tolerance. If one node or 2 nodes goes down, also still it's okay because we have one more replica in place. And scalability, like you can add multiple nodes to the cluster. Security is there, like and it's relatively simple and centralized management is possible. And this framework is optimized for the distributed processing. So, like we go through the different installation modes for Hadoop. So there are like 3 different modes for installation. So one is the standalone mode, another one is the pseudo distributed mode, and the third one is the fully distributed mode. Remember, 3 different modes are there. So in the production environment and all, we use this fully distributed mode. Okay, because there will be like 3,000 or like it will be like thousands of node will be there, and like so that is called a fully distributed mode, and we'll go through each. So like where we use this standalone mode means like it's just comes out of the box and it uses the local file system. If it is a standalone installation, it will never use the HDFS file system, and we never use this for the production environment and all. So in the case of standalone mode, it will use a single JVM container for a Hadoop. So we'll go through all this. And the next one is pseudo distributed mode, and this requires the HDFS. And the third one is the fully distributed mode, and this will run on multiple nodes. Okay, so So we will just start with the standalone mode installation now of Hadoop. So what I did is like I configured one virtual machine. Okay, so I've set up the IP address for that virtual machine as well. The IP address is 94, and I'll use the PuTTY software to connect to that machine. So 192. What is the IP? 192.168.0.94. So this is the IP, and I just logged into this machine. So this is an this is just a virtual machine where I installed the Linux operating system. So here I use the CentOS operating system. If you see the command, this is the command to see like what is the operating system installed. So if you see here, it is CentOS 7.6. Okay, and so we'll start with the installation. Okay, so the first thing what you have to do, you have to log in as a root user and update whatever the packages installed on this. Okay, so the command you have to use is the yum update command you can use. So so I'm telling you, like in the production environment, you have to update with the all the packages and all. And so once the update is done, like you have to restart your machine. Okay, so shut down. I'm not performing this yum update because what will happen? It will upload. It will just download almost 1,000 pages, and it may take some 3 or 4 hours for that updation itself. So I do not have enough time to do that. It's not required. But if it's production cluster, you have to update whatever the packages, like it uh, so you have to do like that. So this is the step one. So I'll share you this note, like you can do this installation later also. And next is the SC Linux. So SC Linux is security enhanced Linux. So it's an ACL, which is access control list, which we used in Linux. So if for installing the Hadoop, we need to make sure that this SC Linux is always disabled. So to disable that, what you have to do, there is an entry here. By default, it will be having the entry like it will be like the entry will be like enforcing by default. So you have to make sure that it is in disabled. So I just disable. You have to add this entry here and just save and quit that file. So it's already disabled. And like to install Hadoop, there is a prerequisite. There are like a few prerequisites. So you need to install the Java program first, because all these HDF, all the Hadoop components run on top of virtual machines only, correct, right? So for that, you can just install this like yum install, and this machine is connected to internet, and it will download from one of the yum repositories are available in internet. So that means like this Java will be downloaded and getting it will install that. See, started downloading that, right? See, now you can see like it's almost the size of that package is 43 MB. It started downloading from internet. So I'm just performing this standalone mode installation of Hadoop. Okay. So let Java get installed. Okay, this takes a bit time. Just hold for that. Mm. Yeah. The speed is very less because it's connecting to internet and it's downloading from those peer stations and all. So it will take time. It takes a bit time. By the time, like if you have any doubts or anything, like you can ask me.
So could you please increase the font little bit?
It's okay now, right?
Yes, yes, thank you.
So this package is getting downloaded from one of the internet hosting website. So that's the reason like it's very slow because of this Java again. So it's very slow now, like a 48 kbps and all. So we'll just have to wait for a few more minutes. It's almost 83% is completed. Yeah, it's 99% now. So it's installing Java. It's that installation started now. Okay. So you see like it's open JDK is getting installed. Okay. So once the installation is completed, you need to make sure that this Java is installed. Okay. So Java hyphen version, and you can see like you will get the output. So whatever the open JDK version and all you will get to know. And next thing is like you need to understand like where this you need to find the Java home directory. So the path which the Java binary is getting installed. So that is what. So for that you can use this command. Okay. So you will see like it's there now. Okay, this path I got now, right? So find the Java home directory that I got now. So now like you need to disable the firewall. So firewall in the Linux to disable the firewall, I can use the command systemctl disable firewall d. So that is a command to disable the firewall. And the Java version, I already checked that. And after that, we can start the installation of Hadoop. Okay, so you can download and install Hadoop. So Hadoop bundle is available in the internet. So this is a URL. Like if you search like download Hadoop archives, so you can see like there are like various distributions available in internet. Like Apache Hadoop 1 is there, 2 is there, 3 3223. This is the latest one, 331. So whatever the version you want, you can just click on that and download from that path. You can see like copy link address and you can download from there. So now to install this, what you can do, change your directory to /opt and download that tar.gz bundle. Okay, so I'm downloading the 2.7.3. We'll see like how it goes. No, this will not work because again it's very slow because from the ISP to this Apache org, the its download speed is very slow. So I just have this in some another machines. So I'll see like whether I can copy from there or what. I'm just copying this star.gz because if I download from internet, it will take again 3 hours, and by the time we cannot finish it on time. So that's the reason I'm just instead of downloading from internet, I'm just copying manually. So if config, I have this bundle available in one another machine. So I'm copying from that machine to 94 node. Okay, so it's asking for the password. See, it's very fast. So almost 24 MB per second. So where I am copying, it's copying to root directory. So you'll see like cd/root directory. See hadoop tar.gz. It's getting downloaded still. Only 95% is completed. So copy is completed. So now like you can see here it is completed. Okay, so I have to extract that because this is a like a tar.gunzip. This is in a compressed format. Okay, so where I have to uncompress, I have to uncompress this thing to like /opt directory. See, it's getting uncompressed now. So it's uncompressed now. Okay. So when you install the Hadoop, like so now like we just completed the installation of Hadoop and we just uncompressed the Hadoop. So we have to define, like a path, like whatever the path we defined, Java home and all. So there are a few entries you need to add in the etc profile. So you have to give the Java home path. So this is the same path whatever I got earlier. So like we will see. Like if you see like it's again links following. Okay. Okay, so this is the path, like that means this user Java default, it's like pointing like this one to here and again another symlink from here to here. So that means like it is like this is pointing to this only. So that's fine. So now I'm just creating a directory, okay, like source. And I'm copying few data. If you see here, like this many XML files are copied to this path, okay. So So I'm just running a job, like a Hadoop job to like, check for a pattern. One second. Yeah, yeah, just a second, okay.
Yes, sir.
I'm redoing that exercise on another node, okay, because I got into some issues. Don't have enough time to fix those and all, like because I had some another distribution running on that. That's why like I got into kind of errors and all. So that and I copied few files to this like this path. Okay, I mean to say like inside this directory opt hadoop etc hadoop. I had few XML files. I just copied to this source. This is a path. Okay, inside this path I just copied those files and now we will use the Hadoop. Because Hadoop we copy to OPT Hadoop 3.30 path. So just give that path in this environmental variable, which we define in the etc profile and source this one etc profile. Just change that path Java home path. So I'm just giving that direct path to the Java. This is a path and give this execute this source command and after that try to run the MapReduce job. We'll see like what's happening. So see now like if you see the command like JPS and all, it's not showing any Hadoop JVM containers because this is a standalone like a standalone installation we did for the Hadoop. Okay, so this see the first type of installation we completed now local or standalone mode comes out of the box easy to get started and this uses the local file system not HDFS and this is not at all used for the production environment. Okay, that's the like a that's called a local or standalone mode. So what I did Here there are no Hadoop daemons running. Okay, see, like if you type the JPS command, it is not showing any Hadoop daemons running on top of that. So top of this box. Okay, so what I did, like I just fire this Hadoop command manually, and this has the like various classes for the map reduce job. So what this command actually did is like it's like grepping this source directory with the or like a keyword called principal, and that output is getting redirected to slash output. So if you see here like a ll out, you can see like there is a file created because we ran a Hadoop job here. So dot zero success, because there is no keyword with the principal. So we'll do one thing, we'll try some another keyword. Directory exists. Okay, directory one. Just a second, okay. Okay, so I ran a MapReduce job using the command Hadoop. Okay, so this is a command which I used. So what I did here, if you see here, like I have an input directory called this one, like slash source. Okay, so if you see here, if you go to this path, you can see like n number of files are there. So you how many files are there? 1, 2, 3, 4, 5, 6, almost 10 or 12 files are there. So what I'm doing, like so I just ran a Hadoop code like a like a Hadoop jar, and I am just giving that a jar file. This has that required class for that running that MapReduce job. So what it do, it will just grab this pattern. That means like this configuration, grab this configuration. This is just a like a keyword only. This configuration is this entry is present in almost all these file. 1, 2, 3, 4, 5. I'll show you. Grep this configuration, how many times it is repeating? It is repeating 1, 2, 3 times in this file. So I ran a MapReduce job to find the configuration, how many times it is repeating in all of these files, 1, 2, 3, 4, 5, 6, 7, 8. So this is the Hadoop command for performing that job. So Hadoop jar and give that a jar file which has that class for running that MapReduce job. So what is the job I am doing? Like this is the source in that I am grepping for the pattern starting with the configuration. So I did that, and where this output is getting redirected. So that output is getting redirected to this path. Okay, new output. So if that job is successful, that means like we ran an Hadoop job here. So if that job is successful, it will just create a file called underscore success. So if you see this, you can get to know that that Hadoop job was successful. So we ran a Hadoop job, that word count job only it is okay. So if you see here cat see 21 configuration and like with the dot also 6 are there. 21 times this is repeating and 6 times this with this dot entry it is repeating. So this is like an this is called this standalone mode installation. So this is just for your understanding only. Any question in this? You can ask, okay, because I am not sure like whether you got it or what. If you have any questions, like you can ask me.
No, sir.
You understand what I did, right?
Yes, sir. Up to some extent we got it, sir, but we need to do some practical to understand more, sir.
Okay, okay, fine, yeah. At least you understand, right? I was just grabbing this pattern using the Hadoop command, correct, right? That is what
Yes,
I
sir.
just,
Yes.
yeah, okay. Yeah, so this is called a standalone mode and nobody uses this mode for anything, okay? So this is just for your understanding purpose, I did this. Clear, right? Yeah. So now, so this is completed. So now next is the pseudo distributed mode. So in this, like, you know, like you will have, like 1 second. DFS to list the HDFS file system. So see, in the case of standalone mode, it is like this only. It is showing like it is showing the native file system only because we do not have any, you know, like HDFS in place for the standalone mode. So that's the reason like it is showing like this. Okay, and JPS also there are no JVM containers running. JPS Java process stack means like there are no JVM containers running here. Okay, so now installation. So now next is pseudo distributed mode installation. So we work on this itself. Okay, 1 second. Pseudo mode installation, you need to create a user called Hadoop. Okay, so for that we will create like this. So this is a command to add the user. Okay, so Hadoop user is already there existing. So if you see here, user add -m -d and like this is the home directory for the Hadoop user and this is the bash shell and this is the username. So this user ID is already created. So you can just uh, type and see that, you know, ID Hadoop means like it is already created. So this is the user ID, group ID, all these are already created. And now you have to set up a password for this Hadoop. So how to set up the password for the user? So password command is here. So Hadoop, I'm just giving the same password for this Hadoop user. So that is done. So now you have to switch your user to Hadoop. Okay. So su-hadoop and after that SSH keygen. So I'm just creating a like a RSA DSA key. So these are these what it did, like it just created an RSA private public key combination. Okay, so this later you can see here. Private key also you can see here. Okay, like this it will create and just run this command. Zero, zero. Now try to log into the same node itself. So if you see here, SSH 127.0.0.1, that is called loopback address. That is the same, like this is pointing to the same KRB1 node only. Okay, so if you see here, yes, it's not looking for the password here, correct, right? So that's a bit, it's because we just enabled the passwordless authentication. Exit, so KRB1. So we already downloaded the Hadoop. So Hadoop export. Yeah, because the step is same only. Okay, because what we did is like cd slash home Hadoop. So I have that Hadoop path installed here. Okay, home Hadoop and Hadoop 3.0. I'm creating a sim link pointing to like this. Now just change the ownership of that directory. Okay, so now like if you see here SCI for Hadoop, and you have to give that path like Hadoop, Hadoop environmental variable. Give that path pointing to new, like because right now like we are doing the pseudo distributed mode, so the path is changed because I copied to this path home Hadoop like this. JVM, that Java home, it's same only. Okay, so I just copy to this path and see profile, and because we just changed a few things. So like we need to edit the one environmental file variable file. Okay, so that Java home path we need to define in this file. This is the path export Java home. This is the path. Okay, so so this path in that there is an for configuring the Hadoop like in the pseudo distributed mode in the Hadoop home directory etc Hadoop env.sh you need to define this path. So that's what I did now, and go to this Hadoop home path. So you can see like where I am. I am in this home Hadoop etc Hadoop. Okay, so this is a directory. So inside that, like Hadoop will have like multiple configuration files for the like if it is HDFS file system, you need to that entries will be present in this HDFS site.xml. So if it's like a processing related, I mean to say like a map reduce processing related, it will have like we have to add those entries in the yarn site.xml or map red site.xml. Like there are like multiple files are available. So whatever the environmental variables which is required for the Hadoop, that we need to define in the Hadoop env.sh. That's what I did now. I just set up the Java home path in this, and now what I am going to do, I am going to do like a few modification to the like core site.xml, one of the Hadoop configuration file, core site.xml. Okay, so what I will do, if you do, you have to add any entries between this configuration and this slash configuration. Okay, if it's Hadoop specific. So now like what I am going to do, see property. Host name. What is the host name of this machine? It's karb1.openl.net. Okay, so I'll do like I'll just add that host name specific entries inside this. So core site.xml. See, I just added this property file system default file system. So this is the port like HDFS, and this is the host name, and 9000 is the port for the name node, and the name node will be running on top of this port. So this entries you have to define in the core site.xml. So that is I did this now. And next file is the Hadoop distributed file system specific configuration, which is hdfs.xml, and you need to define appropriate entries for the HDFS as well here. So for that, open that file, and under the configuration, just add these below parameters. Control C, property. Okay, so I just added a few parameters here. So properties, this should be having spacing. Okay, so you can see like two directories are there, dfs.name.dir and dfs.data.directory. So like at the time of starting, already mentioned that like name node saves its metadata information, correct, right? Like look about the location of the file, where the blocks are residing, all those details will be saved. Uh, all those details will be saved in the name node. So where those metadata informations will be saved. So those metadata information will be saved in the path dfs name.dir. So that is pointing to this path. That means Metadata, that information will be saved inside this path. You understand, right? What is metadata? Metadata means like it's like an like a imagine like you will have a text page. Imagine that first page will be having like an index page will be there, right? So this chapter is residing on this page. Chapter 2, like blah blah blah, and page number 204, like that, right? It's like an index page. Imagine like that only. Okay, so like so this has that details, metadata. That means like where the data is present. All those details will be present in this path, dfs.name.dir. Actual data, that means like actual data in the form of blocks. That means like if it is like a 200 MB file, I told you 128 MB is the block size. In that case, two different blocks will be created by the Hadoop. So first block and second block, where it will be residing, that blocks will be residing in this path, dfs.data directory. So here in this case, Hadoop home Hadoop HDFS data node, like this is the path where the actual data will be getting saved. Okay, so that configuration is done now. Now mapred site. So we have to create those directory, because right now this directory is not present, right? Like this path. So for that, mkdir command you can use. Okay, I just created. So if you see here, uh, you see like this is existing or what, LL. Oh, 1 second. So this path is not created. So for that, what is the command? Like this is the command, mkdir cat hdfsi.xml. So we have to see that this path is created or what, right? ls-ld and see like so this is created now, and you have to see that data directory where the actual data blocks will be residing. So that is also created now. So now next, what is the next step for the pseudo distributed mode installation? You need to edit the mapred site.xml. So for that, what you have to do, like here you can have like inside this configuration, between this, you have to add the entries, because like what is this MapReduce framework name? So which framework we use for the processing? So we use the yarn framework, okay, which is MapReduce itself. So we just define that parameter here. And again, yarn site.xml for the processing layer. This mapred site.xml, this is a like this is the configuration file for the processing layer. And again, yarn site.xml, this is again same only for the processing layer. You need to edit this file. So yarn site.xml, and what you have to do, you have to like awk services. So this entries should be present there, like insert and like so just add the entries in the yarn site.xml. So like again like so we like so what we are doing now, we are just installing the Hadoop using the pseudo distributed mode. So in that case, like what are the things we did? We just created a user called Hadoop. This is a user. So I just shown you that user add command, right? So like that we created the user, and after that we like in that just downloaded that Hadoop bundle from internet, so and uncompressed it in this path. So it's like here now, correct, right? So inside this, I'm just modifying you few like configurations inside this path. These are the various configuration files we need to modify based on our requirement. So like I just modified all these files. Okay, so now first thing, like right now, like this is this first time we install this, right? So we need to make sure that this HDFS is formatted, Hadoop distributed file system. So for that, uh, so I just ran the command HDFS name node format, and now I have to start the name node and data node daemon. Okay, so like I'm getting an error like this HDFS name node user is not defined, something like this, correct, right? So for that, for resolving that error, so what I have to do is like I have to go to etc directory and go to Hadoop. That environmental variable is there, Hadoop env.sh. So this is the file. So if like I need users there, like I exported that, right? Similarly, like I can give like what is my HDFS name node user, so root, and data node user is root, like secondary name node or like resource manager root, like all those details you can define in this file itself. Okay, so that's done now. So now, so go to again where we have to go. So like So what we did so far, like we just made the changes to all the Hadoop specific configurations. Like we just define the Hadoop like a data directory path or like name node that data directory path. What is the host name of the name node? What is the port name? That 9000. We define those details in the HDFS site.xml and all. And once you are done with the configuration change, you have to start your cluster. So that you can start and stop the cluster using the binaries, which is available in the path home Hadoop, and under this sbin directories, right? Binaries. Here, like you will have n number of shell scripts available for starting and stopping the cluster. So start all.sh. So this is the command to start all the services. Like there will be like an or five services which is required for the Hadoop. So right now, like we are not doing like that. So because we are doing the pseudo distributed mode. So start dfs.sh. So I just wanted to start the name node. Oh, sorry. So I typed stop. It's already stopped once again. So what I did is like I just done with the installation of the pseudo distributed node, distributed mode, okay, of the Hadoop. Okay, so if you type the JPS command, see, you remember previously, like in the standalone mode, there was no Java containers launched. So here you can see like, it's like a container is launched, name node container is launched. This is a Java process, okay, or like a Java program which is running on this KRB1 host. Again, data node is that this is again like a Java container which is running. This is the process ID. And the secondary name node also is running on top of this. This will take care of the checkpointing. So if you type like so now right now like the name node is started and the secondary name node is also started here, right? So now like if you see like hdfs dfs -ls slash command and all, you will be able to see. We'll see like it's working or what. So I'm just going to create a directory called hdfs dfs -mk. I'm creating a directory hdfs dfs -mkdir slash data. So I just created a directory inside the hdfs file system. So this is a command to create a big directory. So hdfs dfs -ls, and if you see here slash and see dfs -ls slash, you are able to see that directory is already created, correct, right? It's there. So now this is an HDFS file system, not the local file system. OK, so the difference is like I will show you. So if you type here like I have a cd slash home slash hadoop. OK, so I just created a file vi sri.txt. OK, so I just created a file. Hello, how are you? So I just added a few lines in this, and now like if you see here, you are able to see that file, right? It's read.txt. So I just want to upload this file to the HDFS file system. Okay, so what the command to use is hdfs dfs-ls, and just to see like what are the directories available in the HDFS file system. So I have a folder called slash data. So I'm just uploading like one that is read.txt to that HDFS file system. Okay, so HDFS dfs hyphen put and give that file name and the destination path in the Hadoop distributed file system or HDFS. So like this, if you give this file is getting uploaded to the flash data directory, which is in the HDFS file system. So if you see now like HDFS dfs hyphen ls, so this file is uploaded to the HDFS Hadoop distributed file system. So if you want to see like a C, with the native Linux command like cat and all, it will not work because this data residing in the HDFS file system. So how to list the contents of an file which is uploaded in the HDFS file system? You know that path in the HDFS. This is the path. So the command you can use is HDFS dfs-cat and like this. So if you see here, it's reading from that HDFS file system. Hello, how are you? So this is the content inside that like that file. So now like what we do, like we go through like mm, some few basic command. OK, so like like HDFS command reference, we go through that. So if you're not sure on any commands, what you can do, like you can like hdfs dfs hyphen help is there, and rm. Like so why we use this rm command, you can delete any files. So that is the reason, that's what we use it, correct, right? And uh, hdfs dfs hyphen mkdir. So it's a command to, if you want to make a directory inside the native Linux file system, for example, I'm just creating a directory in my Linux box. So what is the command? Mkdir slash user test. OK, so I can use that like hyphen p, like because that directory is not existing. So I just created this path. OK, in the where it is created ls hyphen ld. This is created here only. Similarly, I can. So this is the Linux, this directory residing in the Linux. OK, that's why like I am able to execute like this ls hyphen a ld. If you give, it is showing that. Now I am going to create a new directory in the HDFS file system. So HDFS dfs hyphen mkdir, same path, like it's in a, this is not native file system because I am using the HDFS. So what it did, it created a directory in the HDFS file system because what it is showing user directory is not existing. That's why, because parent directory is not created, right? So first you create the parent directory slash user. After that, under that slash user, again you can create this. So now see what is the difference. Okay, so this user test, this is in the native Linux file system, and this, what about this user test? So hdfs dfs -ls -d. See, check the file permission and all. So both are different, correct, right? See, this is root user group, and this is the in the HDFS file system path. Okay, so I showed you how to create a. So you, I hope you understand like the commands to create the directory. Can you like just can someone tell you understand what I did or what?
So we got it.
Like you can ask, okay, because it's okay, because in one day you cannot learn everything, because this is itself like, you know, within 3 hours I have to show almost at least some basics. That's what the agenda. But if you are not sure, like or not understanding, you can tell me now also. It's okay, clear, right?
Yes, sir. It's clear, but we need to just practice it out so we can get to know the commands properly again.
Okay, okay. So this is a command. Like if you want to perform any operations on top of Hadoop, HDFS, DFS. Okay, and whatever that operation, MKDIR, RM, or whatever the things you can do. Okay, so this command I already shown you. Like you can just create the directory, and for example, and the parent directory is non-existing. User test ABC blah blah blah. For if you want to create this, to create this folder, parent folder should be present there, right? Or to create this again, this parent should be present, and to create this test again, parent should be present, right? But right now nothing is present. So if you create the, if you use the -p, all this directory one under this under this again abcd and dfsd, like this it will be created. So that's what the option -p we use it for. So if you see, we can test like it's created or what, hdfs dfs -ls -d, and you can like see. Okay, so now this directory is created under the hdfs. So now like if you want to list the whatever the files and all, like dfs-ls, if you want to list whatever the directories and files under the HDFS file system, so this is the root of the HDFS. So it's showing like how many directories are there under this HDFS root file system. Slash data directory is there, slash user directory is there. So this is not a native Linux. Okay, so if you type C, will you be able to move to this directory? No, it's not possible because this is HDFS file system. You have to use that HDFS option to access anything in that. Clear, right?
Yes, sir.
Yeah, okay. So if you want to list the recursively, HDFS, DFS -ls -r, one more option is there. We'll go through that. So what it do, it recursively search whatever the files and directories present in all the folders and subfolders. See, data is the directory. Under the data, sri.txt is also there. Under user, one test folder is there. Under user test, again one more folder is there. And under this, again one more folder is there. So recursively it is searching and it's listing whatever that contents inside this. Okay. And if you want to delete any file, rm command is it, hdfs dfs -rm, and like for example, you have a file data/3.txt. So I'll cat that file. Okay. So cat. What is the content inside that? This is the content. So if you cat by using the, it's not in local file system, correct, right? If you see, it's not there because this is an HDFS path. That's why HDFS DFS hyphen cat, it's shown that output. Okay. So now what you have to do is, I want to delete this file. So this file is residing in the Hadoop distributed file system. So what is the command to delete this file? So the command to delete is hdfs dfs hyphen rm remove. This is a file. I am removing this file. So it's showing it is deleted. So can we list that file now? hdfs dfs hyphen ls, because it's deleted. What it's shown? No such file or directory. So that is, we use the rm command for. Okay. And if you want to delete whatever the subdirectories under the or files under that user test, you can use that -r option. Recursively, it will delete whatever that, because if you see here, test under test, ABC is there, like that. It will delete everything in that. Okay. So if you want to delete the user test, HDFS DFS RMDIR command is also there. User test, if you want to delete, this is a command RMDIR. Okay. Okay, if you, I will create it again, HDFS, DFS hyphen MKDIR, and like this I created. So now I am just, so if you want to see that directory, what is the command? HDFS, DFS hyphen LS hyphen D user test. It's present now. So to remove that directory, what is the command? RMDIR. If I delete, it will delete. That directory is getting deleted. Okay, so now if you test it again, it's not present because I deleted it already, right? See, no such file or directory. So now how to copy a file from local file system to Linux file system? I already done this, correct, right? Because I created like I have a file called news. Okay, cat. This is a file with some like blah blah characters in this. Correct, right? What is the size of this file? This is in native Linux file system. I mean to say like this is in the operating system only. Present working directory inside the home directory path, home Hadoop path, this path DUI from SCH, and see like what is in news. It's a 12 KB file. If you see like a DUI from SCH news, it's showing you like 12 KB is the size of the file. And I just want to upload dfs-ls slash. So if you want to upload this file to any of this path, say like a slash user, what you can do, hdfs dfs hyphen put. Put means like you have to write what you want to upload. News file I have to upload to slash data directory in the HDFS file system. So like this you can give. So what it is doing, it is uploading this file from your native Linux file system to HDFS Hadoop distributed file system. So if you see here HDFS DFS -ls, where it is uploaded, it is uploaded in the HDFS file system. So it's in like data slash news, it is there now. Okay. So similarly, same as like HDFS DFS hyphen put, we have another command. Say like HDFS DFS copy from local. This is same as like our put command. So the only difference is like the command is different. Okay. So news, I'm just going to copy to a different folder. Say data slash data. It will copy from local file system to the HDFS. So what it is showing, like it is showing that news is already existing there. Correct, right? It's because we already uploaded it. That's what. So I'm just uploading to user path. See, it's a like it is same as like a DFS put only. So if you want to list HDFS, DFS hyphen ls and slash user. Yeah, so you can see that file is uploaded here. So if you want to list the contents inside that HDFS DFS hyphen cat, and you can give that path user news. See, it's in HDFS file system, so I'm able to list whatever that. Similarly, I uploaded to HDFS file system, correct, right? So sometimes we may have to download that also, right? This news I want to download. Similarly, like a news, I am deleting this file from local file system. Okay, this is the native Linux file system. I deleted it. So I just want to, download that file. So what is the command to use? DFS get file name is news slash user news. So this file is getting downloaded with a name. Once again. See, I am downloading I am downloading this file. Get means like downloading from this HDFS path to the dot means current directory. If you see here news, that file is downloaded now. What time it is downloaded? It is downloaded at 16:13. So see 4:13. What the time, right? So now only it is downloaded. So now it is in the native Linux file system path. So cat news means like it is showing you that, right? Yeah, that's how it is. So now the file is residing in the, so inside this HDFS, I'm deleting this file, okay? HDFS-rm, and I'm just deleting this file. Uh, so now if you see here, okay, so I just wanted to copy this data slash news to, this is a file in the HDFS file system. So I want to copy this news file to the path slash user, which is again in the HDFS file system path. So the command to use is hdfs dfs-cp. What I want to copy slash news, like this you can copy. So it's copying this file from this path to slash user directory hdfs dfs-cp. See what happened now? It's copied or what? It's copied. See the difference? Under user, it is copied now, right? So that is inside the HDFS file system. It's copied. So now like so if you want to see the distributed file system capacity, what is the disk space used? You can get to know like -df, like you can use this option. Okay, so we are not using, see, the total space available for the HDFS is this one, available is 1 GB, and out of that 40 KB is used because I just uploaded some 20 KB two times, right? 20 KB is this news path, and this news also 20 KB. So total 40 KB is used for these two files residing in two different paths. That's why like a 40 KB is used. Okay. And this is a name node URL. Okay. And with regards to like you can list the files in HDFS like this also, HDFS dfs-ls like yeah, like this also you can list. Okay, because this is a like with that name node URL also you can list whatever that inside that path. So you can see like under this path like slash is the root, under this slash data and slash user is the result. Okay, so it's same equivalent command is htfs dfs-ls slash, both are same only. See, but here it will list with the like you know, with respect to the name node URL path, it will list. Both are same only. Okay, only the thing is that by in display it will show you that name node specific URL. That's it. Now HDFS DFS-du disk usage. So for example, I just want to know like HDFS D. Let me fire this command. Okay, so I just want to see like what is the disk space usage of the slash data directory, which is HDFS directory. So this is a command you can use. See what is the use. So you can see like a 9. This is in bytes. This is the usage. Okay. Hyphen H human readable like in the megabyte or like that it will show you that okay it's 9.2 KB, and again HDFS DFS cat to list the contents of a file which is residing in the HDFS. I already shown you that. So to siphon set replica, so I just want to change the replication factor for the file. Okay, so HDFS siphon slash. If you see here, I have only single node. This is a like a pseudo distributed mode, means like it is a single node only. So far like we were talking about the pseudo distributed mode. So this is the single machine. Okay. What is the name of the node? It is like this one, KRB1 dot like blah blah blah. Okay, like what is that? I'll tell you those like openhelp.net. It is just a simple domain name. It can be like a bit depend on your like a company. Like it can be like yahoo.com or whatever that. This is just an host name I mean to say. So here like this is a single node. Pseudo distributed mode means like if you start the Hadoop, it will be like multiple JVM containers for Hadoop will be launched. So this will be like a single node cluster. It will be like a resource manager will be launched here. A node manager will be launched here. Like a name node will be launched in this container, and secondary name node also will be launched in this container. Like there will be like multiple containers will be launched on the same machine. So how to list that containers? JPS. So like it will show you like this, whatever the containers JPS command. So this type of environment is called pseudo, pseudo distributed mode. Single node will be there. This is clear, right? Hello, hello. Hey, I'm audible, right?
Yes, sir.
Yeah, okay. So like you have any question in this pseudo
No,
distributed?
all clear.
Yeah, because why we use this pseudo distributed mode? So for example, if you are a developer, okay, like and you are writing the or some kind of you are just creating few Hadoop specific applications and all, and you do not have any Hadoop cluster in place because Hadoop cluster means like it's very costly and like you need to have like multiple number of nodes and all. So as a developer, you are not looking for any kind of these kind of things because you just wanted to test your code on Hadoop cluster. That's it, right? So for those kind of purposes, we can use we can configure a single node with the like this pseudo distributed mode. Like we can install the Hadoop on top of this, test your code on top of this jar files and all. Like Java program you can write, you can run that Java program on top of this single machine itself, so that like you can test whether it's running on top of Hadoop or what like that. So that's the reason so mostly like developers use this pseudo distributed mode. It is good for testing, debugging, and prototyping. That means if you are a developer and if you are developing some kind of Hadoop tools or something, definitely you can install a single node like a single node cluster in your laptop itself, as like whatever I did, and you can write that code in like clips or like NetBeans or whatever, create the jar files, copy that to that HDFS path, and like our native in the Linux file system, and you can upload to HDFS and run there that code from there itself. So that's how you can do that. Clear, right?
Yes,
uh,
sir. Yes, sir.
yeah, so now like we go to the fully distributed mode. Okay. uh, Fully distributed mode means that is the actual Hadoop how it will be. Okay, that means like in the production environment we use the fully distributed mode. That means like for example in a big companies and all, like for example any company, like, okay, if they are having the Hadoop cluster, there will be like thousands of data nodes will be there. Okay, like thousands of data nodes will be there, and two name nodes also will be there, which are the master daemons. Okay, two name nodes, one will be active and another will be standby, and uh, all these are the data nodes in the cluster. There will be like a thousands, 2000 number of nodes will be there. So this kind of cluster, this is called fully distributed mode. Okay, because here if you see the in a single node only, name node is running, data node is running, secondary name node is running. If it is a fully distributed, it will be like a name node will be running here, standby or secondary will be running on another node. Okay, resource manager, it can be running on another node. Okay, this is a resource manager. Like there will be like a Hive server, like lots of it will be all will be running on different nodes only. So this is kind of cluster is very costly. So how many nodes are there? Like in a production cluster, there will be like almost 3,000 or 5,000 nodes will be there, because like it will parallelly process multiple data sets. That means like what I wanted to say, see, uh, so say we need this one of the end user. Okay, so he has a single file. Imagine this is a fully distributed mode. So we need this there. Okay, so he has a single file. The capacity of this, the total size of that file is, say this is abc.txt. Okay, so and 128 MB is the block size which is defined for this cluster. Okay, this is a global configuration value. Okay, so this is already set up. So if it is like in a 1 TB file, imagine 1024 MB. 1 TB is 1024 MB, correct, right? 1024. Okay, sorry. 1 GB, imagine like
It
that. Okay,
should be more, right? Yeah.
second, 1 second. So Okay, file size is 1 TB. Imagine
It
like,
should be 10 lakh megabytes.
yeah, 10 lakh megabytes, right? So it will be 10 lakh megabytes means like, see, it will be what Hadoop will do. Hadoop will split based on the default block size. Correct, right? Correct, right? Block size I define 128 MB, right? Correct, right?
Yeah.
So it can be like, like a 10,000 or 20,000 number of blocks will be there. So if it is like, if you upload this file, that means like if we need to upload this file using the hdfs dfs -put command, where what will, this is the block 1, this is block 2, block 3, block 4. Where this block 1 will go? One of the data node, okay. And two replicas also will be there. If the replication factor is 3, this will be like, because for like for the data redundancy, that means like if you have one copy, if this node goes down, data will lose. To avoid that scenario, we will have like a replica will be there. 3 is the replica config. That is again a global value. In production cluster, it will be 3. Again, second block. This can be here, here, or anywhere on 3 different nodes. Okay. Third, here, and it can be here, and it can be here also, like that. Understand, right? So that means like this single file blocks are scattered in all the nodes. Understand, right? That's how the Hadoop like a distributed file system concept, how it is. Clear, right? On this, what I said.
Yeah.
Okay, so now like, so what I was telling, like, so we were talking about this one, right? Fully distributed mode. So in the fully distributed mode, so like I already installed the fully distributed mode cluster, okay, because I cannot show you in 1 hour or something like that. So it's already installed. I will show you like how I configured, and I can tell you what are the all those details. Because if I start from scratch, it will take maybe like 6 or 7 hours for this single installation itself for the multi-node cluster. So so in this case, like I'll show you. So if you see here, cat/etc host. Okay, so 3 nodes are used for this multi-node cluster. Okay, so this how many nodes are there? Like so 1 second, we'll start from scratch again. So this is my cluster which I am going to show right now. Like I am going to show you the pseudo distributed mode is completed. The pending topic is fully distributed mode. So I'm just going to show you like a fully distributed mode now. So I have 3 instances, 1, 2, and 3. So host names are, if you see here, cat/etc host. How many nodes are there? 7, 8, and 9. HTTP 7, HTTP 8, HTTP 9. Okay, so here how I am going to configure it is, this is uh, this is HTTP 7, HTTP 8, HTTP 9. So here first node, what are the components will be running? Name node will be there, and here also standby name node, because high availability is there for the name node. If this goes down, this has to take care of the like metadata and operation, like because why we use name node? To save the metadata information, right? So standby name node, and another Java containers like a data node will be running here. Here also data node is there. Here also data node is there. And on the first node, what else? Like for the like job processing, we have the resource manager component, resource manager. is running here, and then zookeeper will be there. Then what else? Set case zookeeper failover controller. Like multiple diamonds will be there in the multi-node cluster. So here also zookeeper will be there. Journal nodes will be there. And also zookeeper will be there. Journal nodes. And, node manager. Here also node manager. Also node manager. Running there. Okay. So data node. So this is the architecture of what I'm going to do. So it's already installed. So if you see here, like what I did is cd/opt. Okay, so not cd, yeah, user local. At the user local, I will download that Apache package, Hadoop package. So this is the Hadoop 3.30. So if you see here, the same directory is copied to all the remaining nodes in the cluster, user local Hadoop. Okay, that means like HDB 8 also will have the same architect, same contents inside this path. Okay, so now if you see here, uh, etc. First thing what you have to do, you have to make sure that the configuration changes are there Hadoop. So vi like first thing is like for the HDFS Hadoop distributed file system, the configuration file you have to edit is HDFS site.xml. So if you see here, vi HDF XML, see you have to define like what is the total replication factor which is required. I told you like in the production environment it will be 3. You have to define that that single block will be replicated 3 times. If you put 5, that single block will be replicated to 5 different data nodes in the cluster. And DFS block size, you remember right, I was telling you 128 MB, that will be the block size. So based on that, that file will be split. So here it is in bytes. Okay, so this byte if you convert to megabyte means like it will be 128 MB. Again, DFS name node name.dir. This is a path where the name node keeps its metadata. That means the data about data. That I told you it's like an index of the page. So where this specific file residing, like which data node it is, which block it is, all those details will be kept inside this path. That means like inside this only the metadata details will be saved. Okay, and data node data.dir. So under this path only the actual data. That means this is a native Linux file system. But if you write anything to HDFS file system in the backend, that will be getting written to this path and this path. Two paths are defined. Journal nodes, again like it is for the saving the metadata information only. And here you can see like DFS name service is there. Like this is the name of my cluster. My cluster is the name of the cluster. And I told you like if you see here, like I have the name node running here and standby name node running here. So imagine like if it is a very big cluster and somebody powered off this name node, what will happen? You will not be able to read any data or you will not be able to write any data because that metadata service is down, because only name node knows where the actual data or blocks residing. So we can, in a production cluster, we need to always make sure that there is high availability configured for this name node service. So in production cluster, there will be one node which will be name node, and like another node will be standby name node. So here I am configuring high availability. So that means like if somebody powered off this name node, this standby will become immediately will become the active name node, and that will serve the read and write request. So that's the reason like I HA name node services. I enable HA service. HA means highly available service for the name node HA. So two nodes are participating. Which are the two nodes? This is the JNN1 is the first node, which is my first node HTTP7. JNN2 second node. It's again here. You can see two nodes are participating, and you can see like name node that port you have to define in this file, and HA fencing that you can leave it now, and the checkpoint directory. There are like lots of parameters are there. Okay, and so this is just mention all those active and standby name node details and all here. And similarly, like a yarn site, I'll define like yarn specific. That means like processing layer. What is the resource manager IP address? What is the port used for the resource manager? All those details, resource manager, memory, and all those parameters I will define in this only. Okay, like core site.xml. So now I also do have the limitation on teaching each and everything here, because this is a very vast topic, and if you go through all, like it will be like there are like thousands of entries are there. I cannot teach this is just an I just wanted to give an overview, like what is HDFS and all those like that only, because within this short span of time I have to show all this. That's the problem. Okay, that's fine. Okay, so what we have to do, we have to edit all the required configuration files. It's a multi-node cluster. That means the daemons will be running on multiple nodes. Okay. Previously, it was on a single node, all the daemons, Hadoop daemons running. So here in this case, all are running on multiple nodes only. Okay. So I done with the change, and again, like if you see the uh, HDFS side dot, what is that, Hadoop env.sh. If you see like here also, like you have to define like environmental variables. Where is the Java home? Which user this name node should run as? Like then zookeeper, like lots of parameters are there. You have to define all those in this environment. And so that's it. We done with that. Okay, so now so in a cluster, I'll just tell you one thing. See, this is a cluster. Right now, this is the active name node, and this is the standby name node. Okay, this is all the services are highly available. Okay, so imagine a scenario like like somebody powered off this name node, somebody powered off this node, like they removed that network card or something. There's somebody powered off this. This is the name node. Like this has all the daemons. Data node service is also running. Name node service is also running, because in a single node itself, multiple daemons can be ran. So like somebody powered off, immediately the standby name node has to become active. Correct, right? So how this will happen? There should be somebody to watch this, right? There is a code in this is called like a zookeeper. There is a service called zookeeper. What is zookeeper? Because like if this goes down, somebody has to watch this, and if this guy is always keep a watch on top of this, whatever the service is running in this cluster, this service is called zookeeper. So if the zookeeper goes down, this guy will understand that this is down. He only will inform the standby name node, sir, your active is down. Please become active immediately. Because master is down, you become the master now. So this is called coordination service. Okay. So for this, so this service like a zookeeper is the name of the service. This is the coordination service we use in the cluster. In most of the different type of clusters, we use this ZK. So this zookeeper will be running on top of like three nodes. Here also will be running. Here also will be running. Here also will be running. So to start, so okay, cluster. I have like a small lightweight utility called cluster shell. Group means like a zookeeper groups will be having, that will be having some nodes, or like this ZK is pointing to local. So if you this is a cluster specific configuration details, you have to define inside the local.cfg in this path. So name node is pointing to this path. Okay. What are my name nodes? Name node first two nodes with IP 90 and 91. Zookeeper means first three, 90, 91 and 92 IP. These are my zookeeper nodes. Journal nodes, first three nodes. Data nodes, again it is a three node because I have only three nodes. All means like all the nodes in the cluster. So if I want to start the zookeeper service, I have to start this ZK server.sh. This zookeeper is installed on ZK service. This node is it is installed. This node also it is installed, and this node also it is installed. To start service on all of this, what is the command? You have to give like this. Okay. I'll stop it and start. I'll start again. So now zookeeper service is started. See, if you see like a status. You can see like see one is a leader. So this guy like for the zookeeper also we have the high availability because like this is a leader. There are like this zookeeper guy is keep a watch on top of this, right? If this guy goes down immediately, someone else has to watch this, right? We need to high availability for this. So one more zookeeper is here. So this is the leader who is who is watching all this in this. This is the coordination. So if this zookeeper is down immediately, this will become the leader. He will take care of watching all the demons. If this goes down again, this will become the leader and he will watch all this because it's a coordination service. So that's like if you see here, leader and follower is there, right? That's why like we use a concept like that. So now that is fine. So so now to start the cluster, what you have to do, OPT, oh sorry, user local,
Start all.
yeah, and CD to spin and do that dot slash start message. Like this we can start. See it's starting in all the nodes. Okay, so like we have three nodes are there, right? Name nodes, everything it will start. Already started. It's okay. Like key controllers. Okay. Windows, okay. So node managers, it's already running. It was already started. That's why like it's okay. So HDFS DFS -ls slash. Okay, see my cluster is started. So you can see like this many this is my HDFS file system and yeah, it's already started. So I'm able to list whatever the files inside this, right? So I wanted to see like the daemons running on all the different nodes. Okay, because I told you it is a distributor mode, right? See, this is my first node with an HTTP7. This is my HTTP8 node. This is the HTTP9. In the 7 HTTP7, resource manager is running, node manager is running, then what else? Name node is running on this first node. And in the second node, this is like a fully distributed, right? See, name node is running only here. Correct, right? And in the second, another service is called standby name node that is running here, and the journal node, node manager, data node also running here. Again, this is whatever the required service is, it's running here. Like so, that means like the Hadoop JVM containers are like a distribute. It's running on multiple nodes. That is called distribute like that kind of installation is called distributed, fully distributed mode. Okay, yeah. So now what we can do? So I just want to run a small job, like a map reduce job, okay, to find the value of like pi. So, I just ran a map reduce job, okay. So like how this processing happened, because like I told you like if you run any map reduce job, it will run on top of multiple nodes, correct, right? Because this uses the distributed processing. So see, this is a like a, for the Hadoop, there is an interface for the yarn. Okay, so this is called resource manager. So what I did, I ran a job to perform, like to find the value of the pi, correct, right? So 10 iteration with 100 samples. That is the meaning of this command, and it uses a like that there is a like classes will be there inside this jar file, whatever the Java classes required. So it started running. See. So where it is running, so this is the application, correct, right? So it's in still in progress only, correct, right? So if you see here like application ID, this is the one. So click on this application master. See, this is the job, this is the application job ID. So how many containers are running? Because it will be like, that is job is subdivided to multiple tasks. Okay. If you see here, map, see, like that single task is divided to multiple tasks. That means like see, one task is there, another task is there, 3, 4, 5, 6, 7, 8, 9, 10 tasks are parallelly running. 10 task means like 3 will be running on first node, 3 will be on another 3 node. So where it is running, I am not sure like where it is running. Click on that corresponding task. See, this is running on HTTP 9, correct, right? That means like another HTTP 9 node, this specific small task is getting executed. So what is happening? That big task is divided to multiple few tasks, and it's parallelly running on multiple nodes. So all having a task ID. So now here this 001. See that also HTTP 9 only, and here this is HTTP 9. So this was ran on HTTP 7. Okay, correct, right? See, this is again HTTP 9. Depends, like see HTTP 9. So that means like it's a doing a distributed processing. See, parallelly it is running multiple tasks parallelly. So that's what like the that's how the distributed processing work. So now that means like for that pi value, see it started that job. where it is running on multiple nodes. Understand, right? So how long it will take? See, it is running still. So what is the progress? It's like, it's almost 80% is completed. Correct, right?
Sir, the process of joining happens at both, right? A map and reduce. So where is it shown?
Yeah, okay, okay. Map and reduce. Okay, one second. This job is completed, okay? Clear, right? Map and job reduce is completed now for this. Okay, that task is completed. So you have got that output as well here. See, value of pi is 3.14. Correct, right? So now you're coming to this your question. That job has I'll run another because this job history server is not configured. So I start another job again. Okay. So coming to your question, now it is in accepted state. So basically it's a map reduce job, right? Word count and all. So you might be having knowledge on this map and reduce task and all. So it started running as a map reduce job. So if you click on this application master, okay. So so your question is like how to see like the map and reduce task, right?
No, no. The join operation that happens on map side and reduce side, how does it take place, and like where does it show in this UI?
UI it will not show like so that and not
Okay.
you have to see that logs corresponding logs will be there. Okay, so here it will not show because it is a task specific, right? Map task means like if that container is failing, it will show in like there history server. One second, okay. To see that you have to you have to configure the history server. In that history server you have to click on that corresponding task and you have to click on that corresponding logs and it will show you like what are the steps happened in that, like that only it can be, you can see that details. Understand what I said? Hello?
Okay. Yeah.
What I said is to know that details we need to configure the history server. Okay, again like it's like an like I need to make lots of changes in the cluster because history
Yeah.
server.
Okay.
Yeah, if you click on this, if it is configured, if you click on this, it will show you another interface. Okay, understand, right? Because right now it is not configured. So and it will show you like like that job ID details and because like as like you ask like it will have like a map and reduce containers will be there. If you run any kind of map reduce job, n number of map containers and n number of reduce containers will be launched. So that map container, whatever the container ran, that task IDs will be there. Map task 1, map task 2, map task 3, like that n number of tasks will be there. And if you click on that corresponding logs, it will show you that details and all. So or one second. You asked a question, right? That how we get to know that details. So yarn logs application ID and give that that application ID details like this. Okay. So it will show you like what are the stages it gone through and all. Understand, right? See, mm, it will show you like whatever the phases it gone through. Like see, processing this one like
Yeah.
this app reduce task I use also to like or like one by one it will go through multiple stages. So it's this it's a very big output. So I cannot show you everything. Yeah. So like that. But this is not much because this is a, like that application specific. But coming to that, like as like you said, na, join operation and all. That join operation will all that and all will happen inside that map container only. Correct, right? Because if you run a map reduce job, like n number of map containers will be launched. Correct, right? This output will be again returned to the reducer. Correct, right?
Yeah.
Like this. Like this it will happen. So if you want to know the like whatever the join operation happening here, you have to find the logs from the resource manager, that history server. If you click on that, this m1 is the container id. Click on that, it will show you like a detailed history, whatever the join operation, blah 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 blah. Like it will be like thousands of lines will be there, and you will get to know like those details from there. Understand, right?
Yeah.
Any other questions?
No.
Like probably like if you want like I just for because like you see if you want to practice better like that is pseudo distributor mode also fine. I have a document in place, so I can share with Sangeeta, so also she will share with you guys, so I can give this document to you all, like so that installation step I just highlighted.
Yeah. Basically, it's very hard to like mug up these shell
Yeah.
commands, right?
Okay, okay. So I just created a file, so I will share that with Sangeeta, so you can practice all those. So like yeah, that's how you can learn. Yeah, any other questions you have?
No, that be it.
Yeah, you can if you're having any doubts or any like anything you can ask me like because anyway like it's okay like you can so like so from the career perspective like like there is a, like a huge demand for this for the data for this big data and all. So if you like guys are really interested, go through that. There is like huge demand in the market, like data analysis and all like. So because everything is data, right? So
I will share your number, mobile number to students. If anybody is interested to learn Hadoop and big data in detail, no, they can approach to
yeah,
you.
you can share, you can share. Yeah.
Yes.
So like so in this itself like there is a what I wanted to tell you like there is a huge scope for this. Okay, so even though like I work for like a big data administrator only, so from the admin point of view only, I like I take care of end-to-end installation, configuration, troubleshooting, all those things. So there are like different kind of jobs available in this technology itself. Like a developer is there, analyst is there, like those who write the high queries, all those kind of things and all, and like this is like a there is like a huge number of if you're really interested like there are like ML is right, machine learning and all those are integrated with this Hadoop big data framework itself, like Spark, stream processing. It's very vast. So if you're
So have you used Snowflake?
uh, now like we are in the we are going to use we did not start using it. Yep.
Oh, okay.
Yeah, so what I want to say, like, there is like, if you just take something and like, it's better to learn. So, like, there is huge demand for this technology now.
Yes, correct.
Yeah. So, any other like, if you have any
Okay.
questions, like, you can.
Any questions, students? I think
No.
no. Okay. So, sir, let's conclude the session now. Bhumika, are you there? Bhumika,
Yes, ma'am.
please propose a vote of thanks to sir. Please.
Yes, ma'am.
Yes.
Uh, good evenings, all. I would like to thank Mr. Srijit for gracing us with his knowledge. The session was very informative, and we hope to learn from you in the near future. Also, I'd like to thank our teachers and our college for providing us with this session. Thank you all.
Thank you.
Yep. So we'll wind up with the session. Okay.
Yes.
So
Yes.
you just
Thank you
both
so much.
like, yeah. Okay. So thanks a lot for have a great evening. Bye.
Okay. Okay. Bye. Thank you.
Thank you.
Okay, then, student. Thank you.
Thank you, ma'am.
Okay, I took attendance. You may leave now. It is so much heavy, but we have to see once actually. Hadoop installation is not that much easy. At least you got idea about that, no? Okay.
Yeah.
Bye, students. Okay. Happy weekend. Bye. I'm going to leave now. Bye.